Hi, I am Kimmo Kärkkäinen and I'm presenting our work FairFace, Face Attribute Dataset for Balanced Race, Gender and Age for Bias Measurement and Mitigation. This is a joint effort with Jungseok Chu. The goal of our project was to come up with a better face image dataset. Most of the existing datasets are very racially biased, and in the worst cases, nearly 90% of the photos contain white people. This issue is typically caused by the data collection process. These datasets might consist of photos taken of celebrities or politicians, or they might be collected from a social media site mainly frequented by people in the Western countries. So the resulting dataset contains the same biases as the original sources. This is a major issue when such datasets are used to train real-world systems. This can lead to issues such as the phone camera not recognizing people with a darker skin, or in the worst case, wrong people getting arrested as a result of a facial recognition system giving an incorrect result. Our main contribution is a new, more balanced dataset which contains about 109,000 face images with annotations for race, gender and age. Our dataset is based on the Yahoo Flickr Creative Commons 100 million or YFCC 100M dataset, which is an openly available dataset of photos that have been uploaded to Flickr. As it is infeasible to annotate 100 million photos, we started by sampling images from different geographic locations around the world, hoping to get a balanced set of images. We extracted faces from these photos using dlib's CNN-based face detection library, and we then annotated these faces by using Amazon's Mechanical Turk service. We asked 3 people to annotate the age, gender and race for each face, and chose the majority vote as the ground truth label. If all the annotators disagreed, we acquired 2 more annotations. If we still didn't have a majority agreement, we dismissed the image. As the annotations from Mechanical Turk are not always reliable, we also performed manual verification to fix the most obvious mistakes, such as an adult being annotated as a young child. After having one set of annotated photos, we analyzed the racial distribution of our dataset so far, and we repeated the process by focusing more on the geographic regions that were more likely to contain the underrepresented racial groups. To compare our dataset with other existing datasets, here is a race distribution of some of the most commonly used face datasets. The blue color represents the number of white people in that dataset. In the most imbalanced datasets, 80 to 90% of photos consist of white people, while even in the best cases, this number was still between 40 and 50%. In our dataset, we have roughly similar percentages from different racial groups. We also evaluated our dataset on different classification tasks. We trained a classifier for race, gender, and age using 4 different datasets. These classifiers were then evaluated using a left-out part of each of these datasets to make sure that the evaluation is fair. The first table shows the results on white people, and the second table shows the results on non-white people. On white people, our model outperformed other models in 6 out of 9 tasks. And on non-white people, our model outperformed other models in 7 out of 9 tasks. Even on the remaining tasks, our model was very close to the best performing model. We also took a closer look on gender classification by dividing the results per race and gender pair. This shows that our lowest accuracy for any race-gender pair is significantly higher than when using models trained with other datasets. For example, a model trained on UTK dataset shows significantly worse performance on Indian and Middle Eastern women, while a model trained on CelebA dataset was especially inaccurate on East Asian males. LFWA+ on the other hand was worse for females in general. Model trained on our dataset not only had the highest average accuracy, but it also had the lowest variance between different race and gender groups, so the model is more fair in general. In conclusion, we have shown that our racially balanced dataset can help improve accuracy even on tasks not related to race, such as gender classification. Our image dataset and annotations can be downloaded from our GitHub page. You can find this link from the beginning of our paper as well. Thank you for watching.